Now let's look at a specific type of a differential equation of first order called as a linear differential equation. Okay, this is a first order differential equation because we have a dy by dx and no more higher power derivatives. Okay, and this is linear because it is expressed like this, where you have px and qx which are entirely functions of x. Okay, so whenever you have dy by dx plus something over here which is entirely x based, y equal to something over here which is entirely x based, then we say that this is a first order linear differential equation. Just understand, this could be like this also. It could be like dx by dy plus over here you would have something which is entirely y based is equal to over here you would have something which is entirely y based. Okay, these y and x obviously can be substituted to anything. Okay, so this is a first order linear differential equation. Let us understand how we are going to find a solution to this linear differential equation. Okay, let us define another function g of x based on px like this. I have g of x which I say is equal to e raised to power px dx. Okay, now let us see what do I get if I differentiate it. D by dx of gx is going to be what? Look, if you have e raised to power fx, then d by dx of e raised to power fx is going to be what? It is going to be f dash x dot e raised to power fx, right? So over here I am going to have what? I am going to have d by dx of integral px dx dot e raised to power integral px dx. Okay, let me just take this thing away. Whoops, I'll just get rid of this and I'll now simplify this. Okay, so what I get from this is d by dx of an integral px dx is going to be px. Okay, so I have px e raised to power px dx. Okay, so what do you get? D by dx of gx. This is your d by dx of gx, but my gx is e raised to power integral px dx. So I can replace this by gx. Okay, so this is what? This is px gx. Okay, let us call this as equation number 1. Okay, now what I want to do is I would like to take the original differential equation, which is my linear differential equation, and I'm going to multiply throughout by gx. Okay, so let me just paste it over here, and I want to multiply it throughout by gx. So what I'm going to get is, let us see, I would have gx dy by dx plus gx px into y is equal to gx qx, right? Just realize gx into px is d by dx of gx. So let's substitute this. What I get is gx dy by dx plus d by dx of gx into y is equal to gx into qx. Okay, just look at this term. What you have over here is d by dx of gx into y, right? If you apply the chain rule, what you are going to get? D by dx of gx into y is going to be dy by dx into gx as it is plus dy by dx of gx into y as it is, okay, which is this thing. So now I would replace this with this. So what I have is dy by dx gx into y is equal to what? It is equal to gx into qx. Okay, so this is equal to gx into qx. Let us integrate both sides. What we are going to get is gx into y is equal to integral gx qx dx plus a constant. Okay, so essentially what you get is your y is equal to 1 by gx integral gx qx dx plus c upon gx. Okay, you have taken this gx over here. Okay, so essentially what you have is the solution of a first order linear differential equation, which you get by this. Your y is equal to 1 by gx into integral gx qx plus a constant upon gx. Okay, your gx is defined by this. Okay, so if you have been given any first order linear equation, differential equation, you can calculate your gx and then simply put in this formula to get your solution of that first order linear differential equation. Okay, let's look at a question. We have over here a differential equation which we need to solve. Okay, if I simplify this, what I would get is dx by dy plus x upon y log y is equal to 1 by y. Okay, so now you can see this is basically a first order linear differential equation. You have this guy which is totally a function of y, and you have this guy which is totally a function of y. Okay, and this is dx by dy instead of dy by dx. If it is dy by dx, then you should have plus something which is totally a function of x into y is equal to something which is totally a function of x. If it is dx by dy, it is the other way around. Okay, so this is my linear differential equation which I get by simplifying this. I know the solution for this. Okay, what is the solution? Solution is given over here. Just understand one thing. Your gx is also known as an integrating factor. Okay, so I'll just write it down, this terminology for you. So this is also mentioned as an integrating factor or an IF. Okay, so what is gx in this case? My gx is e raised to power integral px dx. Okay, so in this case my gx is e raised to power integral px, which is this thing. Okay, which is 1 upon, it is e raised to power 1 upon y log y dy. Okay, since we have dx by dy, so we are going to have a dy over here. Okay, so this is my gx, or also known as an integrating factor. Okay, if you are going to integrate this guy, just take log y is equal to t, and you are going to get 1 by y dy is equal to dt. So what you have is e raised to power log of log y. Okay, which basically is equal to log y. Okay, so your integrating factor now is, integrating factor or gx is equal to log y, right? Now my solution can be given by this equation. So I'll just copy this and paste it over here. However, since we have the equation in terms of dx by dy, we are going to just replace x's with y's. Okay, so what you have is your x is equal to 1 upon gy integration gy into qy dy plus c upon gy. Okay, actually this is your gy rather than gx. So your gy is log y, so what you have is x is equal to 1 upon log y integral gy again is log y qy. What is qy? Qy is equal to 1 upon y. Okay, so log y into 1 upon y dy plus a constant of integration upon gy, which is log y. Okay, so now if you integrate this, what you are going to get is your x is equal to 1 upon log y into log y whole square by 2. Okay, look, if you put log y as t, what you are going to get is 1 by y dy as dt. Okay, so you would be able to integrate it and you are going to get t square by 2 or log y whole square by 2 as the integration. So you have x is equal to 1 upon log y into log y square by 2 plus c upon log y, or in other words your x is log y by 2 plus c upon log y. Okay, so this is your general solution for the given problem, which you simplified into a linear first order differential equation. Okay, your solution is given by this formula. Okay, when you have dy by dx terms available. Okay, if you have dx by dy, then you simply replace x by y and y by x. Okay,